Hello, everyone. That's a little bit loud. Okay. I'm Tyler. I work at Uber on the Go developer experience team, and I work with.
And Zhongpeng, I'm also the same team.
Cool. So today we were planning on making this talk a little more interactive than the other talks. So I first wanted to get a show of hands on who writes Go code generally in their day-to-day. Okay, less than I was expecting, actually. And then of those, how many of you use Rules Go and Gazelle? Okay, so most of them, as expected. So today we are planning on talking about a few of the major pain points we've seen over the past couple of years, and then talk about some of the workarounds we have or potential solutions we're thinking about. And then while we touch on these, we're hoping to get some input from those other users of these or other people who have interacted with these problems and see what your thoughts are on this, as this is a community day. All right. Okay, so the first issue that we've run into is the design of nogo, which is our static analysis tool for code. Basically, it analyzes code to make sure things are structured properly and similar to a linter. But it's built inside of the compile action in the Go compile PKG, which means that currently it breaks your build when you start compiling it, and there's an error there. And this works well for small repos because the user gets feedback pretty quickly. But when you have millions and millions of lines of code, every single compile action is dependent on this nogo config file. So this single file is breaks the cache whenever it changes for all of these compile actions. So we've found this to be particularly painful, and internally we've found workarounds to make this a little less painful. I'll let Zhongpeng talk a little more about these workarounds.
Yeah, so like Tyler said, we have the nogo has to be configured globally. You have this global list of nogo analyzers. But if we have a monorepo with hundreds of teams, and some of the teams have their very team-specific nogo analyzers, there's no way for them to configure it locally for their team. They have to go to our team's approval, saying, "Hey, I want to add this tiny nogo analyzer just for our team, just to include this part." And this is very painful. And whenever they need to change, okay, I want to include this file or exclude that file, it invalidates the whole cache of the whole monorepo. And we have this change target calculator to calculate all the changes that's affected by every line of change. But once you have edited the go no go change, the change target calculator returns every go target for the whole monorepo. Basically, it means that we have to rebuild the whole monorepo. So we basically have to add a special logic to our change target calculator, saying that ignore all the changes of nogo.json. This is more like a hack than a regular a good solution. So what we are looking for is that if we can implement the nogo analyzer to be a way so that we can break down into specific libraries. One thought from actually the design was mentioned in one of the Jay Connor's posts, saying that there can be breakdown into the top-down analyzers or bottom-up analyzer. Basically, either configure a nogo analyzer for target and it will apply to all the analysis to everything it depends on. This is called top-down. And then the bottom-up is the other way around. Like if you configure it for one target, then everything depending on the target automatically get that nogo analyzer. So this is much a nicer way of having the current situation. And the other way to avoid this cache issue is by using nogo as a validation actions. So basically break the nogo out of the compilation action. It means that first, if you break nogo, if nogo finds error, the compilation still goes on. And the other is that if you change the nogo configuration, it doesn't invalidate the compilation cache, because compilation and linking is the most expensive part. So One of the compilation, validation action has already a pull request opening is in progress, and we still call for contribution of the top-down or bottom-up analyzer or any other ideas that could make nogo be more local and team-specific.
Great. I think for the interest of time, we'll move the discussion to the end. So the next large pain point we've hit a lot is the Go modules not working properly with generated code. So what this means is if there is a certain Go dependency that doesn't exist in source code, but it's generated from like a proto library or something, that import path will not be recognized by Go modules. And so when you run go mod tidy, it will pull in these extra dependencies that don't exist, and it will fail to download them, and then it will break the build. So yeah, we've had to find workarounds for this, as this is pretty common across many repos that use Go with Gazelle. So I guess I'll first talk about the first solution. I'll move it on to Zhongpeng for the second. But the first solution is you just check in all your generated code. This is not a great solution because when you edit the proto library that generates the Go file, you need some sort of validation to show that that generated code has been properly updated, which is why we solved it with this other hack.
So yeah, so the checking in generated code doesn't work for Uber. Our generated code are several times larger than our regular Go code. So if we check in the generated code, our Git repository explode. And we have a separate talk about how to optimize Git repository. But even without generated code, we already need a lot of optimization on the Git itself. So we can check in generated code. So what we did is actually try to work around the limitation of Go mod tidy. The main thing is actually Go mod tidy trying to see if it can resolve all the dependencies in the input from the source code. And what it's looking at is actually the import statement of every Go file. And whenever it sees imports that cannot be looked up in the same repository or resolved from internet, it will fail. And that's the case for our generated code because you can find those generated code on the internet. And so what we are doing is that we have special tool to scan all the source files in the repository. And we basically prepare a special Go file containing all the import path that's in the whole repository. But during the process, we filter out all the things that already known to Bazel. The things that is in the repository, checking the manually written code. The generated code that's already declared in Bazel target. So if, for example, if for those Go proto library, you already have the import path there, so it's known to Bazel. Or the third-party libraries that already declared in the Go repository rules, it's also known to Bazel. So basically, we take all the import path, all the imports minus all the imports that known to Bazel, and then prepare their special file, and then run a Go mod tidy in that file, which will produce the go.mod file and go.sum file. Then we copy it back to our monorepo. So in the monorepo, it looks like a regular Go module file, but the actual Go mod tidy is not running in the monorepo; it's in the shadowed space.
Yeah. So there's been discussion previously if we can try to move this logic into the Go tool, the Go mod tool, but it seems to be pretty tightly coupled with the Go module source code. So there's definitely an ask on other teams if they've found solutions to this that we haven't. But that has definitely been a big pain point for us. All right, moving on to our last discussion. I'll make this quick. With migrating to BZL mod, we've noticed that our module.bazel gets really, really large. And the main reasons for this are that in Go, we load each external dependency with a use repo argument. And this is because in Go, we don't know the list of labels that are going to be available from that target. at the beginning. So we have to load them as we have to download them and look through the whole, the dependency to know what labels are in there. So, so we have tons of use repo arguments, and this has been made easier with the creation of what will once be Bazel mod tidy, we think. But another big issue is we have a lot of overrides. So we have about 1,000 direct dependencies, and a lot of them we have to give special Gazelle directives. And also we have to add patches and things to hundreds of different places. And now we use our repository directory structure with owners or metadata files to restrict reviewership to different code paths. And so we say, oh, if you change this code path, you have to get a review from this team. But this becomes much more difficult if all of the patches are being applied in one file. We no longer have this control. We hit more merge conflicts, and it's a bit harder to maintain unless we come up with some dynamic analysis of the file. So yeah, I'll let you talk about the labels.
Yeah, so one of the solution that actually Fabian proposed was to have that macros to convert the import part of Go into Bazel labels. In that case, we don't need the long use repos arguments. And one of the work in progress is from Bazel team is to be able to load other BZL files into module.bazel file, so that in future we can hopefully split up the module.bazel file into maybe a dozen or maybe 100 files belong to each team. That will make it shorter to read.
All right, that is all of our stuff. So yeah, questions and comments, thoughts on from your teams if you've hit similar things? Yeah, you got it.
So where was the question? Maybe first of all, let's give a hand to our speakers. And then any questions? All right, then. Thank you very much.